Consider a particle moving on a trajectory and says find the velocity at all times. So let's find the velocity. Velocity is the derivative of the position, which is differentiating cosine gives you a negative sign, and because 2t is nested, you have to use the chain rule. The derivative of 2t is 2. Derivative of sine is cosine, and then derivative of 2t is 2. Finally, ln of anything is 1 over, so you get 2 times 1 over cosine t, but then the chain rule says you have to differentiate cosine, which gives you negative sine t. Okay, so you would be getting negative 2 sine 2t, 2 cosine 2t, and then I would say sine t over cosine t is tangent, so this would be negative 2 tangent t. Okay, now find the unit tangent vector. What is the unit tangent vector? This would be the unit tangent vector by definition is you normalize the velocity vector, because velocity vector is already tangent to the curve, and all you need to do is make it a unit vector by dividing its size. So this tells us that we better figure out what the norm of Vt is. And what is that? That's a square root of negative 2 sine 2t squared plus 2 cosine 2t squared plus negative 2 tangent t squared. And that is square root of 4 sine squared 2t plus 4 cosine squared 2t plus 4 times tangent squared of t. And sine squared plus cosine squared gives you 1, so that gives you 4. And this is a tricky part here. You may or may not know this formula. 1 plus tangent squared is same as secant squared. Okay, so that gives us, if you factor the 4 out, it's square root of 4 times 1 plus tangent squared of t, which is square root of 4 times secant squared of t. Then square root of 4 is 2, square root of secant is just secant of t. Now there is a little bit more to do here. Since square roots only produce positive values, you should really put a positive value here. Put an absolute value here. So that's a minor point. And maybe I should have, since the remaining ones are questioning what's happening at t equal to 0, I guess we really don't need to do this, because as long as t is less than 90 degrees, this is positive, so you don't need the absolute value. So when I should really have said t is between negative pi over 2 to pi over 2. Under this condition, this is positive and you don't need the absolute value. Okay, but let's just make sure, let's just write the correct answer first. So the correct answer would be, because you have to divide by secant, and 1 over secant is cosine, you end up with 1/2 absolute value of the cosine t times this function here, negative 2 sine 2t, negative 2 cosine 2t, negative 2 tangent t. Okay, so that is the unit tangent vector, and what I was suggesting is that maybe you don't need that. You can just leave it as without the absolute value. And that's actually really necessary for c because you can't differentiate with this absolute value. So let's continue with that. So what are we doing again? The tangent vector near 0 would be 1/2 cosine t, negative 2 sine 2t, 2 cosine 2t, and negative 2 tangent t. Now 1/2 can cancel the 2's. Also, this would, if I multiply this inside, you get negative cosine t sine 2t, cosine t cosine 2t, and finally tangent is sine over cosine, so if you multiply cosine, the denominator gets removed and you just get negative sine of t. Okay, so now what is the principal unit normal vector? Well, that is obtained by first differentiating this and dividing by its norm. So it's the normalization of the derivative of the unit tangent vector. So we will have to do two things. First, you have to differentiate this. And that would require product rule because it's multiplied, right? So you get, first, if you differentiate negative cosine sine t, sine 2t, and then leave the negative cosine 2t, no, negative cosine t, but differentiate sine 2t, which is cosine 2t, but there's a 2 in front because of the chain rule. And then if you differentiate cosine t, it's negative sine t, cosine 2t, and then if you differentiate cosine 2t instead, it will be minus 2 cosine t, cosine 2t, and then finally if you differentiate negative sine, it gives you negative cosine t. Okay, I don't have enough room, so it's a little messy, but since it's just asking for the unit normal vector at t equal to 0, rather than having the pains of going through the norm of this entire thing, we will just first calculate t prime at 0 and then try to normalize just there. Okay, so we have, if I plug in 0, sine 0 is 0, so and cosine 0 is 1, so you get negative 2. Sine 0 is 0, and then, oh, sorry, this should have been sine 2t, right? Because you're differentiating cosine. Oh, and then therefore sine 0, they both give you 0. And then finally cosine 0 is 0, so it's negative 1. And therefore n at 0 gives you negative 2, 0, negative 1 divided by the norm of this vector, so it's 2 squared plus 0 squared plus 1 squared, which is square root of 5. Okay. Now, what is the tangential and normal components of the acceleration? Well, for this, you first need to know the acceleration, which is acceleration is the derivative of the velocity vector. And let's go back and check what the velocity vector was. It's negative 2 sine 2t, 2 cosine 2t, minus 2 tangent t. So negative 2 sine 2t, 2 cosine 2t, minus 2 tangent t. So you have to differentiate this, which gives you negative 4 cosine 2t, negative 4 sine 2t, and differentiating tangent gives you secant squared. So that's what you have. Therefore, acceleration at 0 would be plugging in 0 gives you negative 4 times 1. Cosine 0 is 1. Sine 0 is 0. And secant is 1 over cosine, so secant 0 is also 1 because it's 1 over 1, which gives you this. So that's your vector. And now we use the formula that tangential component of the acceleration is a dotted with the unit tangent vector, and then the normal component would be a dotted with the normal vector. Usually the second one is pretty bad because normal vectors are so hard to find, but since we already have the normal vector from part C, we will use this. But a warning is that if you're not asked to find the normal vector, it's a lot easier to just do square root of a norm squared minus at squared. You use the Pythagorean theorem to find a, and that's a lot easier. Okay, so here we have negative 4, 0, negative 2 dotted with, what's the unit tangent vector? It's this one, but we still have to evaluate it at 0 to use it. So 0, 1, 0. Okay, good. So it's 0, 1, 0, which just gives you 0. Okay. So the tangential component of a at 0 is 0, which means it is not accelerating at all. Okay, and this one, still the same acceleration, but the normal component was negative 2, 0, negative 1 over 5. Negative 2, 0, negative 1 over square root of 5. And the dot product is component-wise multiplication, so negative 4 times negative 2, which is 8. 0 times 0 is 0. Negative 2 times negative 1 is positive 2, divided by square root of 5. And that just gives you 10 over square root of 5, which is 2 radical 5. After you rationalize this by multiplying by radical 5 top and bottom, you will find that this simplifies to this. Okay, so that's the final answer for. So the answer for this is that it has no tangential, which means it's not accelerating, it's not speeding up at 0, but it is turning because there's a normal component of the acceleration, and the value is this. That's what we find.